สำหรับท่านที่อยู่ข้างนอกก็เข้ามาได้เลยนะครับก็เดี๋ยวจะเริ่มในอีก2 นาทีนะครับแต่ละทางเราได้ยินเสียงดีไหมครับฝากท่านที่จอยออนไลน์เช็คเรื่องเสียงนิดนึงครับเห็นภาพขึ้นได้ยินเสียงชัดเจนนะครับโอเคครับขอบคุณครับโอเคออนไลน์ได้ยินชัดเจนครับ So I think we are about to start. Yep. And so for afternoon session, I would like to welcome you to the Security DNS with DNSSEC from APNIC with Shane and Awal. Please welcome.
Okay, thank you everyone, and thank you of course to the ThaiNOG team for giving us this opportunity to conduct this tutorial for you. So the next 3 hours or 2 sessions, we will be together. So we have designed this session to be more of a hands-on workshop, and everyone, people in the room, as well as people that are joined online can join the labs. So we'll show you how to connect to the labs that we have prepared. And also we have an academy that you can also use. We'll go through that together within the next few minutes. But prior to that, I think just a quick overview of what we want to discuss for this afternoon. If you guys want to come closer as well, that will be very much appreciated. So make this more of an intimate tutorial for all of us here. That will be great. So while you guys are doing that, let me just quickly explain, maybe go through a bit of overview of what we're going to discuss. First is, of course, a presentation on the DNSSEC technical overview. We'll explain what it's about, what are the changes with DNS, how they do DNSSEC validation, and all the new resource records that are introduced as part of DNSSEC. After that, we'll have 2 parts into DNSSEC, and that is validation. They will go through that process together. Awal is here today as well, will be helping us out with that. And then the next part, or the other half, is DNSSEC zone signing. So as I've said, it's more of a workshop. So if you have your computers with you, your laptops, we will be showing you a bit later on how we can join with the labs. The last part is on DNSSEC key rollover and management. We are trying to fit in as much of the workshop that we usually do for a couple of days or maybe even 3 days session. So we'll see if we can have time to cover that, but all the materials are going to be there for reference if in case we don't have time to cover everything. For any questions, as we said, please feel free. We have the chat in here. We'll try to monitor that as much as possible. And we do encourage for this to be more of like an interactive session. I know for the last couple of days, you're sitting there and listening and taking in as much information from the speakers, which is good. But for this session, let's try to do more hands-on, so that will be kind of like practice for all of you as well. I've been going a bit quickly on this. So quick introduction of myself. My name is Cheryl, or Shane Hermoso. I'm the current training delivery manager for the Southeast Asia and East Asia. I'm also a network operations engineer, and just a few months ago, I've been part of the APNIC team for a little more than 10 years. And actually, even before that, I have implemented and done DNSSEC on our zones and our domains, and that was like 15 years ago. So I'm not that old, but just telling you, DNSSEC exactly is not a very new technology, but we've managed collectively to do quite a lot, like from signing the root zone, signing the TLDs. So if you have domains now, should be easy, should be very much doable for you to implement DNSSEC. So that's myself. Maybe I'll pass it on to Awal quickly to introduce himself.
Thanks, Jane, and welcome everyone one more time to our today's session. My name is Awal. I'm one of the trainers at the training delivery team at APNIC. Um, Together with Shane today, like she said, we are going to cover the technical details of DNS and DNSSEC, and I hope that after the session, you'll get a very good understanding of what happens with DNSSEC when we implement it in terms of address resolution or name resolution. And I look forward to your interactions, your questions, and if you have questions that you want to ask later on, we are here around this today, and maybe you can reach us over our email addresses or by other means. Yeah, looking forward to a good session. Thanks, Jay.
Thank you very much, Awal. These are the resources that we have for you. If you can, I don't know, take a photo and then, or we can also post the links on the chat. The course materials are in our wiki page. We also have provided a SharePoint link because generally people tend to want to ask anonymously. So that is the page where you can post your questions that maybe we can all look a bit later on to answer. For any questions that are kind of like outside of today's session, or maybe you're implementing DNSSEC at some point and you would like to maybe get some help, you're stuck with something, you're getting some errors, then we have a community trainers mailing list. So you can post your questions there. So we also have Discord channel. That's the link. So you can again post your questions there for all of us. So I hope you managed to get the links to that and then download a copy of the presentation as well as the lab materials that already uploaded in there. Now, before we proceed, I would like to take this opportunity to also mention something about a really good program that APNIC has. We have a community trainers group. So community trainers are experts in the community in topics that, like routing, security, systems, DNS, etc. And so we would like to tap into these local experts to help us deliver sessions or do technical assistance, help build the community locally. And right now, we don't have any from Thailand. So I hope if if you are in this room, in this session, online or on site, that if you have some interest to join us to become our community trainer, that will be really good. We have two parts into this. We have voluntary community trainers. So usually less time and less commitment are required for you, only based on your availability. But we also have a retained community trainer, and we are actively looking for that person. Retained CTs will commit about 10 days of their time in a month to again help us either deliver trainings and help the community in Thailand. It's also a plus because obviously you will be speaking the local language. So it will be a huge benefit to the Thailand community. So hopefully one of you will become our retained CT. The link to apply is there. It's also on the APNIC website. So please, if you or you know anyone, take that opportunity to become one of our community trainers. All right, so enough of that. We go to our topic, which is DNSSEC. So we have a bunch of people in the room. So maybe just a quick raise of hands. How many of you are sort of familiar or heard of DNSSEC before coming into this workshop? And your goal is to implement it at the end of this session. I think Nan already has BK Nix is already signed. All right, great to see that. How about people who are totally new? Maybe you just hear this word in passing, and you're here to learn more about it, and maybe later on, maybe think of whether you can implement it. So more for knowledge, right? So I think that's most of you. So we'll go through all of that necessary technical details and information throughout this session. So thanks for answering the question. So all right, let's start with a very important question, which is why. The why is always the most important part, because that is how you would know, or you would be encouraged to use the technology. So why do we need DNSSEC? I think it's good to look back or step backwards a little bit and understand that DNS is a critical infrastructure, right? It's a critical infrastructure of the internet. It is used to map domains to IP addresses domains, and other records as well. And DNS itself, since it has been available for quite some time, it lacks some of the security requirements that in today's modern world is necessary. So we have a few security protocols, security mechanisms, security best practices that can be implemented to add that form of security into DNS. And one of that is DNSSEC. And so it's good to now ask, what aspects of DNS are we trying to protect? Are we trying to protect the data itself, the information? And in what sense? Do you want to encrypt the message? Do you want to validate the message? So with DNSSEC, we're trying to ensure that the information or the records that we receive, say I ask Awal, hey Awal, what is the address of Nan? And then Awal will give it to me, right? But how can I validate that it is correct, that it's coming from the right source? Something like that. This is a very general analogy. So in that sense, we want to know that the DNS data, the DNS record, or the DNS information that we receive is valid, it's not tampered, and it's confirmed that's coming from the correct source, which is the authoritative source for that domain. So how do we check the validity of this DNS data? We will be using DNSSEC. And how do we implement that? In this session, we kind of have a few, I would say, prerequisites. So some knowledge that I hope you already have coming into the session, because we won't have time to cover for that specifically, and one of that is crypto. So we are actually implementing DNSSEC using cryptography. So these are the different DNS vulnerabilities, and as you can see, there's quite a lot. From querying records, to updating records within the servers, to clients needing to get that information or get those records from the cache, which then communicates with the authoritative servers to get those information. So everywhere we can have corrupt data, we can have cache pollution, unauthorized updates, cache impersonation. And our focus with DNSSEC is the second part, which is data protection. So we're trying to prevent cache impersonation, cache pollution, and data spoofing. So DNS cache poisoning is preventable with DNSSEC. So what is cache poisoning? So I think the name itself is, to some extent, is quite self-explanatory. We want to poison the cache, DNS cache, so that any client who is querying this cache will get tampered information, and in that sense are led to access or connect to wrong servers, wrong sites, fake websites that is created to fool the user to get their credentials, okay, or get them to divulge their personal information. So DNS cache poisoning, just very high level discussion here, is pretty much something like this. So this part is your typical DNS query. Client goes into the DNS recursive server. Recursive server goes into a recursive query from the root until it finds the authoritative name server. And that will be able to give up to the answer, which is the IP address in this case, with the corresponding query ID. Now, with DNS cache poisoning, you have this like a fake user, a malicious user that wants to then give wrong information into the cache, like so. And then from that, okay, it tries to pollute the cache by sending a lot of information into it, hoping that one of these information will match. So basically, I'm telling the cache the IP address for the domain that you're looking for is this, which, as you can see there, is not exactly correct. So the red ones are fake, the blue ones are correct. So if it is successful, that means your client will now connect to the wrong server, which is exactly what we don't want to happen. So that's a very high level overview of it. If you want to read more about it, there's a few really good articles and papers that I have posted in there that describes DNS cache poisoning in detail. Now, what makes this worse is because like some of the DNS applications earlier on are using query IDs that are sequential, meaning if your query ID is in that case 64571, the next will be 64572, etc., right? So kind of like it's guessable, which at this age in time is not good because you can always script it. You can always send a bunch of responses by automating it and hoping that, one of that will match. So that is DNS cache poisoning. And as I've said, the solution is to validate that the DNS responses that you're receiving are actually coming from the correct authoritative source. So you've seen this initially, and what I want to show there is DNSSEC kind of protects you from cache pollution, data spoofing, and cache impersonation. So at this point, the next question would be like, all right, so how do we implement that? We use crypto, right? Cryptography. Cryptography provides confidentiality, integrity, authenticity, and non-repudiation. But which one do we actually need for DNSSEC? We mentioned earlier that we're not really focused on encrypting information or encrypting data. Our focus is on validating the information. Okay, so for DNSSEC, we are our requirement is for integrity and authenticity. Okay, not really concerned about encrypting your DNS data. So how do we use crypto for that? I hope you're familiar with digital signatures, right? So with public key crypto, so PK, you have two keys, one public key and one private key. Use one key to encrypt, use the other to decrypt. Or for digital signature, you use one, usually the secret key, to sign the message, and you use the public key to then validate that the signed message is correct. So that is kind of the idea here. Okay, you hash the hash of the data, the hash of the message. Okay, think of like signing your emails. It's a bit like that, but in this case, we are signing DNS records. So you sign the record. The hash of the record is signed using the private key at the source, and then this data or this record plus the source signature will be sent or forwarded to the destination, usually when you query for that record. When it is received on the other end, the hash of the data will be like decrypted, like we use the public key, right? So I kind of like have the signature there, and if it matches, then you know that it is correct. You have verified information. So that is how digital signing works. So essentially, we are using that for DNSSEC. Obviously, we'll look at more details, but that is a good way to understand what DNSSEC does. Next part is going into technical details. So DNSSEC stands for DNS Security Extensions. As we've already mentioned, it provides or it protects the integrity of DNS data using digital signing, which then provides you with a way to establish authenticity and integrity of your data. And the other part there that we will be talking more as we go on is using trust. So it's not just about signing the data itself, but we rely on a hierarchy that will then ensure that you can verify that signature. And that is by following what we call as a chain of trust. Okay, so how DNS works is this one. I hope everybody is familiar with this. A very simple query from the host to the recursive DNS. Recursive DNS then looks for the authoritative DNS. It's a recursive query. This is very simplified, but it finds the authoritative DNS to get the answer, in this case, the A record. Then the authoritative DNS responds with the corresponding A record, which then is forwarded to the host. Simple, right? Looks quite simple. So if we implement DNSSEC, how does this change, or how is this updated? And it's a bit like this. Again, still quite simplified, but gives us an idea of how it works. So host, same thing, sends the query to the local DNS, which then will do a recursive query until it finds the authoritative DNS for that. But then, if your authoritative DNS signs their records, these records will also be supplied to the recursive DNS. So it provides information about the record. In this case, it asks for an A record. It provides that. It also provides a corresponding signature for that record. Remember, you have the data or the record, you have the signature of the data. And that together will be sent to the recursive DNS, which then performs what we call as a validation. Okay, depending on the result of that validation, if it found out that it is correct, it matches as we have described before, then it will provide the information to the host. Okay, just the information, doesn't have to include the signature at this point because it's already validated. So from that, you can see that there is actually two parts to it. One is if you are the domain owner. Okay, maybe you have ThaiNOG .or.th or BKNix.co.th or your company domains. You are the domain owner. Okay, so in the DNS ecosystem, your purpose, your goal is to be able to sign the zone. Okay? Sign the zone, then answer the queries for records that have been requested, and also send again the corresponding digital signature for that record. That is if you are a domain owner. What if now you are, maybe a resolver? So maybe ISP or an enterprise network. You provide DNS service to your clients or to your customers. Right? You use a recursive DNS server. So if you're managing that, I think at the end of this session, your goal is to then make sure that your DNS server, your resolver, is performing DNSSEC validation. And that means it will authenticate the responses supplied by the server, they do the validation, and then forward the information to the client only if it is validated. If it's not validated, then there's no sense forwarding that to the client. It should result instead to a serve fail. It's as if the site itself is not reachable, right? Serve fail means you cannot find the record for that, and therefore the client is not able to access that page. So that is the purpose of your validating resolver. So again, two parts into it. If you are the domain owner, you sign your zone. If you are a recursive DNS server operator, then make sure that it is validated. So now, okay, we're still in the how part, right? How DNSSEC works, but this time let's go into a bit more detail. So, right, I know that I need to sign my records. So let's go into that detail. How are we signing that? And where do we put the signature? Where do we put the keys? Like, right? So that's the important part there. Do you put it out of PAN, not part of DNS? Or we make sure that it is part of DNS, which is actually going to happen here. So you have records, your DNS records, A record, PTR records, quad A records, right? Those are DNS resource records. Those are signed, again, with a private key. Now the signatures are published. Do we have to use any third parties for that? Oh, well, actually, we can just use DNS, right? So we are going to have those signatures published via DNS. And what about the key? You need the key to verify the signature. We are also going to publish the key into DNS. Next part, if you have child zones, if you're familiar with delegation, .th, co.th, bknix.co.th, those are like delegated, right? So you have administrators for the subdomains. So if you are a parent zone, which is the upper zone, okay, you sign the zones that are under your your administration. But if you've already delegated child zones, then it is no longer your responsibility, right? So it's now going to be the responsibility of the child zone, whoever is managing that, to sign all the records. It's kind of like independent. There has to be a link between the parent and the child. And again, we should be able to cryptographically verify that that link exists. So we will be adding some records into DNS as part of that. So question now for you is, if you're familiar with DNS, do we have a place to put those records? Do we have a place to put those signatures, those public keys? Just with DNS, probably not, but actually it has been extended to have new resource records that can hold those information. Okay, so it's the same thing, same as the previous slide, but now we are a bit more specific. We are signing what we call as RR set, so resource record sets. We have RR sig that holds the signatures. We also have DNS key. Those are resource records again that will now hold the public key. And lastly, we have DS records, okay, that will contain that information that links to the parent, that links the parent to the child zone. New resource records. So we'll go through all four of those new resource records, but this is a summary of the new resource records introduced. Actually, there's a couple more, but I'll introduce that a bit later on. But these are the main ones. RRSig stands for Resource Record Signature. Maybe I'll go through the next one to explain that in a bit more detail. So in DNSSEC, actually, we're signing not individual resource records, but RR sets, or resource record sets. So think of group of records, right, that has the same characteristics, so to speak. So things with the same name, same class and type. Let's say, for example, you have 3 A records. We'll combine that together, that is considered as an RR set. So in DNSSEC, we will be signing RR sets, meaning you have one signature for the set, like so. So your RR sig here, okay, is the second line. So that is a signature of the A record. So it's signed an A record as an RR type. And this is the algorithm used. Okay, we will show you the different DNSSEC algorithms, but this is type 13. And this one shows the number of labels that it signed. So in the RR set, we have two records, particularly two A records that is signed by this signature. We also have information about the signature expiry and when it was signed. What I think you can notice here is that if it's signed, for example, in April 21st, you can see the date there. So 2022-04-21, okay, it expires a month after 2022-05-20. Now that's not always the case. You can obviously change that, but that is the default. So that means there is an expiry to the signature. Okay, the keys don't expire, but signatures do expire. So that's something to take into consideration when you implement a DNSSEC. The good thing is there are now ways to make that simple and automated. Okay, but conceptually, it's important to understand that signatures, as you can see in here, do expire, and it needs to be re-signed at some point. The next part is your DNS key. So where do the public key goes, or where is it in your DNS? It is added as a DNS key record, something like that. So this example shows that it is a KSK versus a ZSK. I'll explain what those two, but it's essentially your key. And then the DNS algorithm again is 13, or type 13. And this long one here is your public key. Okay, it's now a bit shorter because it's in base 64, but that is essentially your public key. In this example, we have two. One is 257, the other is 252. Maybe I'll use this a bit. Use my laser pointer here. So this one is 256, this one is 257. That's KSK and ZSK, which we will be explaining more as we go on. The next is your delegation signer, or your DS record. So what is a DS record? It's a delegation, right? So it shows that from the parent zone, the child zone has been delegated to another admin, and we add the public key of the child zone, okay, in this format, and then add it into the hash format basically, and then add it into the parent zone. So it might be a bit too much to take all of this in. So, but I hope you do get the idea of what each of these records do, and you'll see more examples of this as we go on. The next important part is your NSEC, or NSEC secure. When you validate something, okay, it's easy to validate if the record exists and you have the signatures for that. But what if there is no record? Like, for example, I have irashai.net, and I have a record, let's say test.irashai.net. And if someone queries for test2 instead of test, right, I don't have record for that. So how do we check the validity of that? So that's the purpose of NSEC. It actually proves the non-existence of a record. And that is by having kind of like a linked list of the records that are following each other. So if you notice in this example here, you have a list. You have an A record followed by an NS record, followed by a SO record, MX. So that is your linked list. So if someone maliciously, inserted or queried for a record that is not there, you will know, because you know that it should be in that order. So that's the purpose of NSEC. One downside of NSEC is this is exposed. You have this in text. which if I do a click for query, I know that there's an A record followed by an NS record, etc. So I can, script this out and potentially get a full list or the full information in your zone file. While DNS is, technically like public information, you don't always want to just give out all the records in your zone file. That's not how it is, right? You always usually have filters to make sure that's only it can only be um, captured by your is it the slave or the secondary server, but not anyone else. So how do we avoid that? We use NSEC3, which will have a hash value of those records instead of that showing as a text file. So kind of like this as a quick example. NSEC allows for what we call a zone walking, which I explained earlier, kind of like lets you do recursive query for all those records and eventually capture all the records in your zone file. But with NSEC 3, technically, it's still possible to do zone walking. It's just not feasible. So there is a difference there. If the cost of having to do this, like a hack or something, right? If the cost is very high, there's no sense doing that. So that's what you're doing. You're making the cost of doing zone walking very high. So the computation costs is high for hackers or attackers. And so there's no sense doing it, or there's no advantage for them doing that. Are there any questions so far? I think all good in the chat, and some information being provided by Awal as well. So just very quickly, we've touched on DNSSEC delegation or DNS delegation, which is like from the parent to the child zone. So essentially, the parent adds the record, that's an NS record, to the parent zone, okay? And then the child zone essentially adds NS records for all the authoritative name servers, plus all the records in that child zone. But when you do DNSSEC, what changes? There's just an addition, right? It adds, aside from adding the NS record of the child zone, in the parent zone, you will also add a DS record of the child zone. That's going to be used for that link. So the child zone will generate a hash of its public key. And that's actually what goes into the DS record in the parent zone. So that's just an additional work for both the parent and the child. This again can be automated, but it's important to understand that concept. With delegation, you would usually add an NS record to the parent. And if you add DNSSEC into that, you will then also provide the hash of that public key to the parent zone, either automated or manually. And then the parent will need to add it into its zone so when you query, you have that link, and that is cryptographically verified. Okay. Now, for that part, I said I'm also going to introduce a couple more records, and that is this. So, and it helps with this DNSSEC delegation. We have the child delegation signer, or CDS record, and then the child DNS key, which provides information to the parent of what information should be in the DS record resource record set for the child. So it usually, it doesn't have to go all the way to the parent. The child zone can add CDS record and CDNS key record, and that gives information what should be added into the parent zone's DS record. Kind of just making it more automated. You can add it from the child zone instead of going, manually to the parent every time you have that new key, UDS keys. All right, and that leads us to chain of trust. So this is an important concept because yes, you can generate your keys, you can assign your records, but how do you know that a zone or an authoritative, a DNS server is the authoritative for the zone? All right, we are back. So chain of trust, yeah, we said that you have delegation, but with if you're adding DNSSEC into the equation, you need to also establish that chain of trust from the parent to the child, kind of like this, right? You have um, this domain here, abc.apnic.net, okay, is basically when you sign your zone, you also create the DS record, okay, and the DS record for that is added to the parent zone, apnic.net, because you need to have that link between them. So again, from apnic.net, there needs to be a DS record added to the parent.net, and then same thing added to the root zone. So you go all the way to the top of the DNS hierarchy tree, which is the root or the dots. Okay, so this establishes a chain of trust, not just from these two, parent and this child, but all the way to the top, which is what we call as the trust anchor. So in this case, since the root is already signed, that will be the top of our chain. In the old days, I'm not sure if some of you have been around then when we don't have the root signed yet, we rely on third-party trust anchors. One of that is what we call as a DLV. Some internet organizations maintain that for some time. So before the root was signed, we used these third-party trust anchors. But now, since the root is already signed, we can trace back. We can easily have that chain all the way to the root zone. So I guess for you, the problem now is just if your parent zone, or in some cases, if the TLD is not signed yet. And believe it or not, there is still quite a handful of top-level domains that are not signed. So what's the purpose of the trust anchor? We said that the root is the top and it's your trust anchor. So a trust anchor generally is an authoritative entity for which, you trust it. Trust is assumed and not derived. Okay, so because that is the start of the trust. So you kind of like make sure that there is an assumed trust between your entity, your client, and the trust anchor, which in our case is your root zone. So DNSSEC signatures are validated, as I've said, following this chain here on top. DNSSEC signatures are validated by following a chain of signatures that leads us all the way to this trust anchor. Questions so far? So that's an example of the root zone as a trust anchor. The next thing to maybe think of here is the use of your public and private keys. So we will have to generate keys because the keys are used to, again, sign your records and validate your records. So how do we implement that in practice? So there's a couple of ways to do that. And for quite some time now, we tend to do the first one, which is use two sets of keys. Why is that? If you remember the parent-child zone setup, it means that whenever you generate new keys, you sign your records, you have new DS records, you will always have to go back to the parent zone, which is an administrative burden. Think of some of the biggest TLDs, .com, .net. Remember how many records they have? Millions of records. And if each of the subdomain will have to, every month or every few years, go back to the parent zone, to the TLD, because they have new keys, then again, it will be an administrative nightmare. So one thing that is being done is to use two keys. One to sign the records. So that is what we call as the zone signing key. And another one to sign the zone signing key. So you have like two levels. You have the key signing key. I think you've seen that a couple of slides back. We have KSK and ZSK. So that's the purpose of that. KSK signs the zone signing key. Zone signing key then signs the records. You have two levels to avoid, too much burden on the parent zone. But there's also a growing use of what we call as a CSK, or combined signing key, which from the name kind of like combines both the functions of the KSK and ZSK into one key for the KSK. So that's that. So these are the types of keys that I've mentioned. Zone signing key, or ZSK, is used to sign the records or the RR sets. The key signing key is used to sign the ZSK, and the common signing key, or the combined signing key, which is used for both. Okay. Now, you've seen in one of the examples in the RR-SIG earlier that actually signatures do have a validity period. It can be 1 month, it can be a few months, it can be a year, something that you set. By default, in most DNS applications, it's set to a month. But yeah, it's technically, signatures do have expiry. But the keys that you generate actually don't. But with anything crypto, okay, when you expose keys, it only takes time, right? It only takes time. And of course, the resources required to backtrace that. So as a practice, it's still always good to generate new keys regularly. Typically, ZSK is generated every year or every couple of years, maybe for some. KSK, maybe a bit longer. So if you're generating ZSK every 6 months, then you generate your KSK every year or every couple of years. If you're generating your ZSK maybe every year, if your records, you don't think your records are not as sensitive, then you generate KSK maybe every couple of years or every 3 years. Again, it's an operational choice for you to do that. Something that you have to decide in like a policy statement before you start implementing DNSSEC. Right? And yeah, remember that when signatures expire, you have to re-sign it. Why? Because, well, it is expired and it will no longer validate. So I remember that chain, your recursive DNS server who is doing DNSSEC validation gets the record, gets the signature, checks it against your DNS key record. If the signature is expired, then it will not validate. So it will not give that information to the client. Client will not be able to reach the domain or the server that it's trying to reach. Now, these are the different DNSSEC algorithms. There's quite a few there. Most of that I've put there are still, well, it's used or they are possible to use. The complete list is in IANA website. The link is somewhere down below. Which one should you use and which ones you should not use? We have some descriptions on the right to give you information about that. In some of the examples I've shown you previously, we have used type 13. Where is type 13? It's somewhere there. It is this one, which is ECDSA. Okay. So type 13 is generally preferred by larger DNS operators because of the smaller or shorter signatures, shorter keys, which means shorter signatures as well, and which means you have smaller DNS packet and you're receiving a lot of queries or millions of queries every time. That saves you a lot of bandwidth, right? So there's a lot of big operators that are moving into using type 13. Even for smaller operators, actually, there is a trend going into using that. For quite a long time, people have been using either type 8 or type 10. Actually, you see more of type 8 than type 10 because type 10, although it is longer, 512 bits, there is not much significant difference between type 8 and type 10. So if you're using type 8 now, which is RSA SHA-256, there's little benefit to upgrading that into 512 bits. So what people tend to do is that instead is from type 8, maybe use type 13 algorithm later on. Now it's important to understand this DNSSEC algorithms because when you start using, let's say, type 8 now, at some point you want to use another algorithm. That is another thing that you will do kind of like a migration into, like change of keys, which may have an effect, and you need to plan that accordingly. So yep, those are the ones that you probably would be using a lot. Now there is also this type 15. And if you are just thinking of implementing DNSSEC now, you don't have that in place. So consider this. Type 15 will become the default algorithm at some point when there is more adoption of this algorithm, which is ED 25519. There is another one, ED 448, which is also recommended, but at this point, it's really not widely used. So the next algorithm that you will probably see a lot is type 15. So if you're going to choose among these algorithms, then it's type 8, which is still majority of the DNSSEC algorithms or being used at the moment. And then type 13, and then, as we've said, type 15 at some point. We have the recommendations from RFC 8624 as well, with which ones can be used for both DNSSEC signing and DNSSEC validation. Okay, I think this one, it's good to check, particularly for the ones that you should not be using. And you know why, right? Because they're weak algorithms that should no longer be preferred at this point, especially if you have stronger algorithms that are available. So if you're still using RSA MD5, RSA SHA-1, DSA, then those are not recommended. Again, type 8, 13 are still recommended and must be supported by your algorithms. So looking at some statistics from DNSSECtools.org, you see here that actually both type 8 and type 13 are the most widely used algorithm at this point. I just checked this, I think this morning or yesterday from the page there. So you have a little more than 8 million for type 8, which as I've said earlier is still the majority of algorithms used, and then type 13, which is slowly becoming kind of the de facto standard being used by most operators. So you have those two as your main choices. Same with ZSK. We have both type 8 and type 13 as well. And I think we have half an hour. All right. Any questions with this presentation? Kind of like there's a lot of concepts to digest, I think, at this stage. So what we can do is go into DNSSEC validation. Okay, so that's the first half of DNSSEC. And then maybe just very quickly before I give it to Awal, to show you quickly some of the resources that you can use if you want to follow along. The first one is the wiki page, which I think was already shown or shared. The link was shared to you over chat earlier. And from here, we have a copy of the presentations which you can download. And for the exercises, we have both the labs that we will be sharing information on how to access a bit later on, but also we have this DNSSEC lab in the Academy. So in the lab that we prepared for you today, there's actually 30 VMs, 30 servers that we can use. So I think for most in the room, that should be enough. But for those that are joined us online, you can also use that. But if it's already taken, then the other option is to use the DNSSEC lab in the APNIC Academy. So a couple of options for you. If you don't have access to the Academy yet, you may need to register, but then allows you to access the virtual lab. This one, which I think gives you about 7 days to complete the lab yourself. So you can start today, and then maybe if you want to redo that or continue working on it in the next few days, you can do it on your own time and on your own pace. So those are the two main things I want you to look into. And yeah, maybe the rest of this I can show you a bit later on. There is a DNS cache poisoning paper that I've mentioned in the presentation, and that's one of this. So have a look. It's very detailed on how DNS cache poisoning works. And then aside from the stats that I have so far shown you, there is another one here, which is maintained by our labs team at APNIC. Yeah, I'll do it like that so we can show the whole screen. This one is DNSSEC validation rates by country, and will be good to see where Thailand sits in the whole world, in the whole equation. The greener it is, of course, you have more DNSSEC validation happening, and the redder it is, less DNSSEC validation. One of the things that kind of like help with DNSSEC validation, I think percentage, is also the use of third-party DNS providers. Most cloud providers, let's say Google Cloud, Cloudflare, Google DNS, and then Cloudflare, Quad9, and a few others do DNSSEC validation. So if there are lots of folks, like in these countries or in these economies that are using those public DNS servers, then it kind of increases the validation rate. So don't feel too bad. Maybe a lot of like local DNS providers are not doing it yet, but in some cases for other economies here, maybe they're relying more on these large third-party DNS providers. But it's good to have a look at this. Maybe consider this when you're thinking of, yeah, I want to do DNSSEC validation. Where are we now as a community? As a Thai community, where are we now compared to the rest of the world? So that's that. I think I'll pass it on to Awal to discuss DNSSEC validation. Thank you.
Thanks, Jane. So now I think we have a good understanding of the concepts of and bits and pieces of the DNSSEC. It's a little bit complicated if you hear this for the first time, but when we do the session and we do the lab, we'll get more confidence with the terms and also the keys and how the DNSSEC works in real life when you apply it and use the name resolution with DNSSEC. Yeah, it's not working. Okay. So it's frozen. Thank you. Yeah, it's working now. Thank you. So just recall that Shane was showing last time is the how you do the DNS query to get an IP address against a certain domain name. Now we are doing the same thing here one more time. This time we would like to see how the DNSSEC fits in the picture. Okay, so here we have on the left side you see a host, and that's gonna query for the with a domain name to get the IP address of that domain name. So it asks its resolver, resolver, what is the IP address of apnic.net? That's a simple DNS query, like the before we have seen that. Now the recursive DNS here is configured by the admin to do DNSSEC validation. That means it is going to do the job for you to check whether a domain is actually secure or not. So the recursive DNS resolver is doing the query to the authoritative name server. And of course, it goes through the root. If it is a new query, it goes through the root and the TLD and so on and so forth until it reaches the authoritative DNS. In our case, let's say apnic.net, its authoritative DNS resolver is on the right side here. So our recursive resolver that's sitting in the middle queries what is the A record for apnic.net along with a bit called DNSSEC OK bit or DO bit. So that's kind of a hint from the recursive resolver to the authoritative DNS saying that if you have DNSSEC related information, also supply that along with your answers. So it's kind of included in the answer now, if they have it. So in our case, apnic.net, that authoritative DNS has the DNSSEC configured, and also the request includes the DO bit. That means it's now going to answer the IP address or A record, and if there is any signatures or keys corresponding to that A record, it's going to supply that with the answers. So it has the sign zone and record, so it's going to answer that to the recursive DNS. Now it gets the information, it does the recursive DNS now does the cryptographic analysis for you to verify the signature and the answer so that it is not a fake answer. So now the recursive DNS is going to reply back to the host with AD bit, which is called authenticated data. So it's actually did the authentication for you and found out, in this case, found out that the answer is authentic. And that's why it, along with the A record, it said the host that this is a valid answer. Okay. So if someone someone pretends that I'm apnic.net and they give you a different answer, then now your resolver will understand that this is fake, and it's not gonna give the host the IP address, the fake IP address. So it will say that server failed, so this is not the right answer. So this way, host probably unknowingly could go to a wrong address, but this time the host is not gonna get the answer. That's why it's not gonna go to the wrong address. So this way, it is actually secure. Now, how the chain of trust is built in the picture of the DNSSEC resolution process. So if you think that host tried to communicate to the authoritative name server, or the recursive resolver tries to communicate to the authoritative name server to get the IP address and corresponding signatures to check or to do the validation, that means the recursive DNS talks to the authoritative DNS and get the information related to the keys. Now, this is just for the understanding of how the chain of trust is built, or how in the back end, how the analysis are done, right? Now, you have the A record already, as you can see on the top right corner. We have the A record for APNIC.net, along with the RRSIG, or resource record signature, for that A record. Now, I can have a signature, but without validating that, I cannot guarantee that this is okay, right? So now my recursive DNS has the A record and the signature, but how do I verify that's a valid signature or not? Now I need to have a key. So remember when Shane was presenting, we had each of the key, we have two parts. It's a pair. It has a public part and a private part. So the private key is used to create the signature or sign your zone. Now we have the public part to verify whether the signature is valid or signed by the authentic server, right? So now my recursive DNS asks for the key. What is the key that signed or created this signature? So the public key is supplied, and now it can check whether the answer is valid or not. So let's say it first looked for the key, it found the key, it verified the signature there. Now it needs to know whether there is a DS record in the parent zone. Now, all the terminologies that we have learned today earlier is gonna be here in this picture. So the delegation signer, or DS, we have learned earlier, right? It's kind of a pointer from the parent to the child name server, something like this. So it's the DO or DS, DNS. So the delegation signer is actually the kind of the smaller version of the KSK of the child. So it is a pointer of the KSK that needs to be added to the parent zone. So the DS is asked to the parent. In our case, it's .NET. So the recursive resolver gets the answer for the DS along with its signature. So now this signature is actually created by the parent with its keys, with its zone signing key, or ZSK. And this way, after that, it asks for the key of the parent to see how the parent used its key to sign that, whether it's valid or not. So the validation is going from the child zone to the parent zone now. And again, once it is verified, it will then ask for the DS record to the root, whether it has a pointer for .NET there, right? So delegation signer is kind of building the delegation. It's kind of verifying that the delegation is already done. So this way, finally, we have the answer from the root, and then the chain of trust is completely verified, as you can see on the left side, right? If you have more here, if we have more level of domains, then it follows the same hierarchy. If you have more, like for example, if we have academy.apnic.net as a separate delegated zone, then we'll follow the same hierarchy as it goes with the domain name. So now the recursive resolver, if it has DNSSEC enabled, then it will try to figure out whether the zone is properly signed and the answer is authentic or not. To enable it in your resolver, it is important, as you can see in the previous diagram, it is important that you have the DNSSEC validation turned on in your recursive resolver. So to do that, if we are using, let's say, bind, which is very, very popular as a recursive resolver, so you can just see that it has by default the configuration in the options that says DNSSEC -validation. We have kind of configuration of auto there, or maybe yes, if you use trust anchor or the key to do that start of the validation by manually configured key. But we are not going to go in that direction. Let's focus on the auto, which means your resolver is going to check or do the validation automatically for you. And as I just explained, that the authenticated data bit or AD bit is it's a flag. It's gonna be added to your query it's gonna be added to the answer to show you that the recursive resolver could successfully validate for a resolution. Here is an example. If you know the dig tool, it can help you troubleshoot the DNS or DNSSEC related troubleshooting. So here we use the dig, and using the @localhost, we are saying that this host is my resolver to resolve www.apnic.net for this domain. And I would like to see the DNSSEC related parameters or information. So that's why I'm just plus DNSSEC flag is added there. And then I'd like to see in multi-lines for additional information. So once you use this in the terminal, in a Linux terminal, for example, and then we can see some answer there. If you see the top line here, it's kind of a snap, right? So you can have more information as an output in your terminal, but this section is saying that the status is no error. That means the query was successful and there was some answer, and it doesn't have any error. And then if you see the flags, the second line, if you see the flags, it has some basic flags like the query recursion or recursion desire or recursion available. So these are okay. This is not related to the DNSSEC, but one additional flag that's really related to DNSSEC is the AD flag or authenticated data. That means your recursive resolver has the DNSSEC enabled, and it could successfully validate the answer, and it's giving you the right answer. That's why it's called authenticated data. It's guaranteed. It is actually giving a guaranteed answer that this is authenticated. And in the answer section, if you see that for the domain www.apnic.net, we have a record, or this is a CNAME record in our case. And for this corresponding CNAME record, we have some resource record signature or RRC, right? And the signature is there. Then if we move forward, yep. So the next slide has, if we have the AD bit or authenticated data bit or flag on, it means that this is authenticated data. But if you do not see some AD, as you can see in the second example, if you do not see the AD, that means that answer, that the validation was won in the recursive resolver and the answer is not authenticated. And that's why it shows the status as server fail or serve fail, right? That means the host is not going to get an answer, and subsequently it won't be able to start the communication because it doesn't have the answer unless it's specifically done. Now, what if your recursive resolver doesn't support DNSSEC validation or doesn't or is not configured with the DNS validation on? What you can do actually? So you can do some online web checks to see whether the destination domain or whether the domain that you would like to access has some authenticated information or whether it is authentic or not using some online tools. Or you can use your browser plugin to see. So there are plugins for your Firefox browser or Google Chrome. You'll see that it can show you with some mark on the browser that this domain is authenticate or some kind of indication whether the domain is actually validated using DNSSEC. So we can use, and I can show you, we have one in my browser added as well. I can show you later that it has a green, notification that the DNS, the domain is actually authenticated using DNSSEC. You can use public DNS resolvers that has the DNSSEC enabled. For example, for the Quad 1, or in our case, we have shown you 2 examples, Quad 1, Quad 8, they are actually open resolvers. You can use them, and they have DNSSEC validation enabled. So at least you can use them and see if you'd like to access or if you'd like to see whether that domain has the domain is authentic or not. Here is an example, or here's a screenshot. On the left side, you see that the certain domain, DNSSEC-failed.org, we are using the DEEC tool to see, without the validation, you can get an answer. So the validation turned on, for example, in this case, and we can access that website. Let's say DNSSEC-failed.org, and you see there is an answer section where we have a record for that. But if we turn DNSSEC validation on in our resolver, that's what happens. On the right side, we see that the status is serve fail or server fail for that exactly same domain, DNSSEC-failed.org, and there is no A record in the answer section. That means it is not authentic. It is not an authentic answer in terms of check when we check it with the DNSSEC parameter or validation on. Similar thing in this page. Without the validation, I can access the website. With the validation, my browser cannot find the destination address to access. So I'm not going to be able to access that with this setup. What can the network operators or network service providers do in terms of helping deploying the DNSSEC? So they can enable DNSSEC validation in their recursive resolvers, because most of the time their customers are going to use their DNS to access domains or to access to do that resolution. But the problem is that if you do, for example, if you are a network operator, an ISP, and you have customers who are using your DNS, now once you turn the DNSSEC validation on, that means those websites or URL that are DNS, they're broken in terms of the DNSSEC implementation. So you are not going to be able to access those. Your customers are going to complain that these websites I cannot use or access. So you need to train your NOC engineers, your support engineers to handle these type of questions and to be able to troubleshoot whenever there is some kind of complaint that I cannot access this kind of website. So they should be able to figure out whether this is because of the DNSSEC validation or not, right? For the end users, if you are really worried about this kind of fake answers, man-in-the-middle attack, and all the other vulnerabilities that we have in the DNS, if you are really concerned about that, so you should use a recursive resolver that has DNSSEC validation turned on. So if your ISP doesn't have this, what you can do is you can use open resolvers that has the DNSSEC validation on, but there are other concerns with that. I'm not going to go in that direction, but if you'd like to use it, you can tell your ISP that your DNSSEC validation is not turned on, and I'm not going to get an authenticated answer, and I'm not so sure whether I'm talking to the right server or right destination or not. This way you can actually have some conversation with them, or you can use another recursive resolver that has its validation turned on, right? Yeah, so this page already shared, shown by Shane already. It's one of our status, running in our lab in APNIC. So it can show you, give you a good idea of per economy DNSSEC validation status. And I think already shared by Shane. So yeah, if have a look at the URL here, if you're interested to check check the current status of Thailand there. So yeah, I think this is it for this session, and we are gonna show the DNSSEC zone signing part. Is it after the break? So I can show you some of the URLs as well. Let me see if I have something turned on here. So like I was saying that you can use a browser plugin. So you can see that this is a browser plugin. I'm just using a Firefox, and you can try with your own browser. You can have a plugin, something like the DNSSEC check or something like this, and it can show you whether this is secure or not. It will give you some kind of red if it is not secure. For the yeah, so I think I'll probably show you these DNSSEC these later on when we finish the signing part. Yeah, presentation.
Okay, any questions with the presentation so far? I'm sure there are. DNSSEC is not exactly the easiest topic. So I can understand if you still have questions in your mind on how it operates, how it works. For most of us in this room and online, I think the first important thing to ask is, hey, is my DNS server doing validation? Right? Because we're all users. We all use DNS. Whenever we browse something, whenever we access via SSH, whenever we send emails, we all use DNS. And understanding the reasons for implementing DNSSEC, which we discussed at the very beginning, is it's important. You want to have that peace of mind that you're accessing correct sites, doing transactions with the correct servers, etc. So for all of us as users, we should check whether we're doing DNSSEC validation. Awal has pointed some information that you can use, some sites that you can use. And just very quickly, I think we can also show a bit more before we pause for a break. And that is also linked on the page, the wiki page earlier. And this is one of them, DNSSEC or not. Very, very simple page. If you are doing DNSSEC validation, see that, are you protected by DNSSEC or not? Or it's doing a test. It essentially checks your local DNS server, what you've configured on your machine, and it will show you some results, whether it's actually doing that or not. So I do encourage you right now to try it yourselves on your browsers. Open this page. Hopefully we don't DDoS the page. There's only a handful of us anyway. But yeah, give it a try. So yep, it's funny. It's meant to be funny, I reckon. Because DNSSEC topic is not it's not easy to digest. So this is a good way of making a fun way out of that. So in this case, we are using the hotel network, the hotel DNS as far as I know. And yeah, good news. It is doing DNSSEC validation. So do that yourselves. Maybe you're in your home network, or maybe in your company network, or a campus network. Or maybe some of you are using your ISP provided DNS. Some of you may even be having default Google or Cloudflare or any third-party DNS provider as your default DNS. So in that sense, you can verify, are you using DNSSEC validation or not? So in that case, in here, we actually are. Now, another thing, this is already, I think, posted, it is in the presentation, but let's just look quickly. Maybe from here. I was doing this while listening to Awal earlier. So doing a simple dig query, similar to what you can see in the presentation. So here I tried to do a dig query for the beginnings domain plus DNSSEC. Multi is really just a formatting thing, because if you don't have that, it will just like make that like a long one like this. So multi, so don't worry about it. It's multi-line, it's for formatting. But the plus DNSSEC option is essentially to give you the corresponding signature. Now you can use this command both for validation and for checking whether the zone is signed. But the important bit for us, I think at this point is, as already mentioned earlier, is the 80-bit. Again, another tool that you can use in your arsenal. If you have a Unix or a Linux terminal, you have the dig utility installed, then you can use this to do simple queries such as this to find out whether your DNS, which in this case, I do a simple dig. That means I'm using a server that's available to me locally, which in this case is this IP address. I can also specify dig at, say if you want 8888. Sorry, I have one hand, so it's a bit harder to type. It's okay. Something like that. Yep, I lost that one. At. So that's the IP address of the server. It can also be a domain, right? But yeah, because it's easy to remember their IP addresses anyway, let's use that. So same thing, it gives you the records, and it gives you this 80-bit, which means that your DNS, which in this case 8888, is actually doing DNSSEC validation. Questions? So that's where we'll, yes.
What are the possible reasons that people don't do DNSSEC validation? Do they just forget, or they don't have time?
That is a very good question. How many DNS operators do we have in this room? No one, because they don't want to answer your question. So it can be a lot of things, right? First and foremost, you need to have people who know about this and confident enough, of course. And to a greater extent, particularly for small, medium-sized organizations, the DNS job, I suppose, is only one part of what your typical systems administrator, sysadmin would do. You don't have a full-time dedicated DNS or zone administrator. And if you're going to take on this job, there's a lot of information, as you're already starting to find out, there's a lot of information, there's a lot of processes that you need to be aware of, you need to know. You need to do some planning as well before implementing, particularly for the signing, right? The validation, I think, is a bit easier. For the signing, there's a bit more. But in same for the same reason, you need a DNS operator that understands how the technology works. And I think that's one of the downsides. As I've said earlier, it's not exactly very new technology. I've implemented it 15 years ago. Quite a number of people have implemented it for some time now. But also, I guess some people maybe still don't see the value to it, because if you're going to spend time implementing it, you first need to understand the why and the how, right? The why first before you get into the how. Yes, are you adding an answer or another question?
I would like to add the answer from the perspective of the users or the clients. There are two kinds of people: those who buy insurance, those who don't buy insurance because they think it's not important until they get sick or their car crash. Then they said, why didn't I buy an insurance? So DNSSEC is an insurance. So there will be two kinds of people thinking about DNSSEC. Those who say, I have to have DNSSEC. The other guys, DNSSEC is not worth it until you get ransomware or something. Then you said, why didn't I turn on the DNSSEC? So that's the answer from the client point of view. So we at our organization end up running our own local resolver, turning the DNSSEC on, because we are buying an insurance. And but of course, with the analogy to insurance, you're gonna have to pay the insurance fee. In our case, it's the record maintaining labor. But that's for the prevention of the ransomware down the line. Not just ransom, everything else. Because people are going to lie to you, saying the server you want to connect is somewhere else. Their bad server is the correct server. That's what they do when they poison the DNS answer. They say the bad server is actually the one you want to talk to. So, like I said, it's a matter of the mentality of people buying or not buying insurance.
Thank you for that. That is a really, really good insight, very profound as well, a very good analogy, and very true. Yes.
I understand that there are some difficulties and need technical knowledge at a certain level for configuring the DNSSEC. So as a normal user who just register with the domain seller, this job should belong to the end user or the domain owner or the domain provider, or it could be happen. I think someone is here that could answer this one. I think they may provide these services with some cost. As I understand, that is the thing that they don't want to buy or pay more apart from only the domain name.
That is very possible. So yes, it can be a feature that can be provided by a hosting, DNS hosting provider specifically. And I think some are already doing that. Some of the biggest DNS hosting providers are doing that. Obviously similar to like managing DNS. You can let the DNS hosting do the that management for you, or you do it yourself. I'm not sure like how much is the extra, I guess, cost for you to have that maintained by someone. But for those who are maintaining domains themselves, which I think is a really good percentage of of people who own domains, because you want that autonomy. You want to be able to add your records. You want to be able to post your own DNS servers. So there is that challenge to be able to set it up yourselves, because you're the admin. You should have the technical knowledge. You cannot just rely on the DNS host to do that for you. But yes, that's a really good insight as well. I'm not sure if there are anyone here who are working for a DNS provider, hosting provider, that can give us some news, like maybe locally in Thai, if anyone is, if they're offering that as a service, as a feature, and if there is any extra like overhead um, as part of that. Good insights. Thank you very much. Any other questions? Do you want to add anything, Awal?
We are in the break time already. I'm just gonna quickly add to that there's two parts. One is the recursion. It doesn't add any cost, I think, unless I mean without the knowledge of adding the DNSSEC validation command or some configuration, because you are running a resolver already. It's there. You're just adding the validation feature turn on. And the other part is the authoritatively answering the signatures and stuffs. That's the second part. So if we are not going to go to that direction, at least with the resolver, it's easy to turn on to protect your customers for the remote domains that you are going to resolve. So I think it shouldn't be, it's just kind of, knowing the things and, updating and having the mentality to update my configuration there, and for the end users, I think if you do not have the option that your service provider having the DNS without the DNSSEC validation enabled, you can still use the open resolvers that has the DNSSEC validation turned on. That could be an option, of course. So, thank you.
Thank you, everyone. I think with that note, we can pause for a break. If you want to do the labs, we will be doing a lot of that in the second half of this tutorial. So this is the link up to the SharePoint page. And we actually have 30 VMs available. So if you're interested to follow along with the demo and do it in one of the VMs, please type your name in the first column, in the first field here, and that will be the server assigned to you. So we will be posting this link on the chat as soon as you can. And then during the break, if you can please add your name next to the server, so it will be reserved to you, that will be great. Yes, for people in the room also, if you want us to do this for you, just let us know, approach us, and we will be adding it into the page. And there's also information on how to access the VMs here. You can try it out during the break. We will also be explaining that once we resume at something o'clock. I think it's about half an hour. Yes. Let's try to come back perhaps in, yeah, let's do a 15-minute break. Come back just around 3:25 if you can, and then we will resume. Thank you very much.